kind of a multi-year effort and partnership with the University of Montana, and we're excited about it. A lot of good things have come of it. And this is just another webinar. We've done several in the process. I know Scott's got, what do we got, another year, a little that less than that in this agreement. And so we're looking forward to seeing the final product and seeing how this can help us with Montana Focused Conservation and other efforts we're doing. So Scott, I'll turn it over to you. We'll take it from there.
Great. Thanks, Kyle. Good morning, everybody. It is blustery here in Missoula, so if you had to have a commute into the office, I hope everything went safely. I know these early season storms make recalibrating to dealing with road conditions a bit dicey. So I am here at the University of Montana. I'm with the Working Lands for Wildlife Science team, led by Dave Noggle. And we've been working with the Working Lands West team, as well as a number of collaborators across Western landscapes to help drive conservation science, allow us to do better targeting, allow us to evaluate outcomes. And the work we're going to talk about today is kind of a culmination of a lot of things. We've been working at the scale of the West to understand tree cover, woody encroachment. And so I'm going to talk a little bit about that. And then we've also, for the last couple of years, been working with the folks here at NRCS Montana to look specifically at some tools and applications to help you guys deal with this threat closer to home. So if you're not familiar with the Working Lands for Wildlife group or science team, we work primarily across two biomes, the sagebrush and the Great Plains. Here in Montana, we're lucky in that we're actually kind of double dipping, or we have both of the biomes represented. And if you haven't seen the frameworks that we've developed, I highly suggest you take a chance to go look at them. They're at WLFW.org. So we work primarily on 4 threats across these two biomes: woodland expansion, land use conversion, exotic annual grass invasions, and riparian and wet meadow degradation. So today I'm going to talk particularly about woodland expansion, but our team are really focusing across a broad set of threats that are impacting our ability to put conservation on the ground across Western landscapes. So the roadmap for today, I'm going to start kind of at the big scale. I'm going to walk you through the science of woodland expansion, its conservation implications. We've had some recent work coming out trying to understand this phenomenon at really large scales. I'll talk about what we're seeing across United States rangelands, and then I'll kind of zoom into Montana and some of the work that we've been doing here over the last couple of years to understand where in Montana this is happening. And I'm going to share with you some tools we've developed to help you with developing your targeted implementation plans or understanding where this conservation threat is happening on the landscape. I hope to talk for about 35 to 40 minutes and then follow that up with some discussions. I'm going to ask that people either put their questions in the chat or wait till the end, because I'm going to try to get through most of this material so we can have some discussion. I will have page numbers on the slides moving forward. So if you have questions on a particular slide, you can reference that number. And then also there's going to be a number of links in this presentation. You'll have the opportunity at the end. I'll put in a link to the slide deck so you can download that. So if there's more information that you're interested in what we're providing, you can click on those links and get to those additional data, those additional resources. So I wanted to start today with kind of a conceptual understanding of what a healthy shrubland is. And there is a really nice website that's just come online, the Pinyon Juniper Project. This was funded in part by Working Lands for Wildlife, led by Jeremy Maestas, in a collaboration with the University of Nevada, Reno. And they've put together a lot of really good resources to understand the threat of tree encroachment across the Great Basin. But much of this applies to Montana as well, to our shrublands and to our grasslands. And, as a place to start, we understand, what a healthy grassland and shrubland looks like. We have a high diversity of perennial forage and grasses. These support forage resources for wildlife and livestock. These are important habitats for obligate grassland and shrubland species. And this high plant diversity makes ecosystems really resilient to disturbance, whether it be grazing or drought. The other big ecosystem service that we see with this high diversity of perennial grasses and forbs is that they're able to put a lot of their energy underground to be more resilient to some of these disturbances, and that also leads to additional carbon storage in these ecosystems. When we see trees come in, though, we see a dramatic change in both the structure and function of these rangelands. The biggest thing that you see is that when we have invading trees, we change the structure in such a way that we see the removal of these grassland and shrubland dependent species from these sites. They're losing their perennial forage that they need to eat. They're losing their habitat. And these large structured trees serve as perches for predators that predate on these obligate species. Additionally, lower plant diversity leads to lower resilience. We're seeing across much of the West, some of these invaded places are seeing additional cheatgrass invasions following woodland invasion. And we're also losing a whole lot of below ground carbon storage as we shift from perennial dominated systems that put a lot of their energy into the root zone to these annual dominated grasses that put most of their energy above ground and don't invest in carbon storage below ground. Finally, what we see in a lot of these drier sites is increased erosion. So as trees come in, perennials go out. We might see cheatgrass come in, but in some cases we see bare ground proliferate, and that can contribute to additional erosional processes. So at a big scale, we're trying to avoid these conversion of these grasslands and shrubland systems into these woodland patches, which have substantially lower perennial perennial diversity in terms of grasses and forbs, and also serve as important habitat for a whole plethora of wildlife. We know that shrublands are in steep decline across the West. About a month ago, our colleagues at the USGS and Fish and Wildlife Service put out a new report, a sagebrush conservation designed to proactively restore America's sagebrush biome. If you haven't seen this, I highly suggest that you take a look at it if you're working in sagebrush country. The first thing that they did is that they went in and they mapped sagebrush habitats across the Western United States. So in the map that we're looking at, these core sagebrush areas are in dark blue. These represent high quality sagebrush habitats. Growth opportunity areas are in light blue. And then other rangelands are these degraded sagebrush ecosystems are shown in tan. And a big finding from this work is that we're losing about 1.2 million acres of high quality sagebrush habitat per year. So this is a chart from their report showing the distribution of core areas, growth opportunity areas, and these degraded sites called other rangeland areas through time. So from 2001, they had about 54 million acres of high quality sagebrush core areas. And in 2020, we had about 33.4 million acres. So we're losing about 1.2 million acres per year of these habitats. They were also able to look at sage grouse populations across these three areas. What they're seeing is that those sage grouse using these sagebrush core areas are increasing in population, so they're doing quite well. Those in these growth opportunity areas are kind of holding their own, but populations on these other rangelands or the other sagebrush degraded sites have been declining. The third important point from this work is that 75% of the work that we need to do for restoration is going to be work on the ground. What we're seeing is that these conversions are not a result primarily of land use change or policy, but 75% is attributable to things like annual invasive grass invasions and woody encroachment. So if we're going to be able to kind of get ahead and start preserving some of these landscapes, we need to prioritize some of these ecosystem threats that are severely and substantially reducing the acreage of these core habitats for sagebrush and grassland obligate species. So, we are working lands for wildlife. Turning to some of the biodiversity concerns that we're working on, I think most of us are probably aware of the substantial decline in grassland bird populations we've been seeing across the northern Great Plains. This is also represented across all of North America. This is a paper came out in 2019 showing that we've lost about 3 billion birds since the 1970s, roughly about 30% of the decline. But if you look here in this area that has been highlighted, what you can see is that grassland birds have it the worst. We've lost about half of these grassland species. Much of this is attributable to land use change, but also there is a significant component that we know that's attributed to some of these ecosystem threats. Again, things like woody, encroachment, cheatgrass invasions. So just as an example, we've been learning for about the past 10 years and some great work coming out of the Nature Conservancy, some of our colleagues in the Great Plains, how some of these shrubland-dependent species respond to tree cover encroachment. So on the left here, we have greater sage grouse in Oregon, some work from Sharon Barak-Murdo. What you're seeing on the y-axis is lek activity. So this is basically habitat usage during breeding season, and then conifer cover on the x-axis. And what you see is that once you get to about 4% tree cover, the sage grouse stop using sagebrush country for their lekking activities. They're stopping to use that habitat. Similarly, in the Great Plains with lesser prairie chicken, we see something very similar. Habitat use here on the y-axis, trees per hectare, and they're seeing that lesser prairie chickens are basically abandoning these grasslands when you get to more than roughly about 3 or 4 trees per hectare. So the good news is that we know how to enact conservation at scale to reverse these trends. So this is some work from Andrew Olson working in the Warner Mountains in Oregon. And what we're showing here is lambda on the y-axis. That's the difference in population growth rate. On the x-axis, we have time. And the lambda rate, or this population growth rate's in dark black with this conifer removed. So this is a conifer removal project they did in the Warners over about 7 or 8 years. And what they see is that as they were able to get to scale, so starting in 2012 through 2014, they removed almost 10,000 acres of conifers from these invaded rangelands. And they saw this response after they got to scale where the population growth rate was bouncing around before, but was able to recover and was able to sustain at positive rates, roughly, I think, around 12 or 13% growth rate. And so they've continued to watch this. This finding is robust. We know that if we can put conservation on the ground to deal with woody encroachment, we can get some of these birds back on the landscape. Okay, stepping way out, we've talked about, what grasslands and shrublands look like as they become degraded. We've talked about these biodiversity implications. I also want to talk just briefly is that this is not something that's specific to Montana or even the Western United States. We're seeing this happening pretty much on every continent, every set of large grasslands across the world. And so there are multiple drivers for what's causing tree cover encroachment or tree cover expansion, changes in disturbance regimes like the removal of fire, livestock overgrazing, increasing atmospheric carbon dioxide can favor trees in some warm growing environments, then also nutrient pollution. So this is basically nitrogen deposition. But in the United States, the primary proximate driver is the removal of fire from the landscape. As Europeans colonized the West, we removed fire, and since then we haven't had that disturbance mechanism that the Native Americans used to such effect to keep tree cover expansion in check. So some work that we've been doing is trying to understand tree encroachment across the Western United States. This is some work that was just published about 2 or 3 weeks ago in the Journal of Applied Ecology. It is open access, so if you're interested, you'll be able to click on this link and get the paper. So we've been looking across rangelands in the 17 Western states, looking at a time period from about 1990 to 2019. And what we found is really astonishing. First, we're seeing tree cover increasing on roughly around 25% of all the rangelands in the West. We've seen an absolute tree cover of about 50% in that time. That's about 19 million acres. So we've added, we've added a dense forest equivalent to the size of 10 Yellowstones across the West in the past 30 years. Not only that, we've converted around 36 million acres of grasslands into woodlands. 36 million acres is roughly the size of Iowa. And we're also seeing right now about 50 million acres that are an increase of about 50 million acres that are vulnerable to tree encroachment. So that's an area the size of Nebraska. So this is a large threat that's affecting rangelands, grasslands, shrublands across the Western United States. What you can see here in the map is that a lot of this tree cover increase is happening in the southern Great Plains. That makes sense. That's a warmer, wetter environment. Tree cover expansion has been persisting there for more than a century, but we are seeing this signal that these increasing as we move from south to north and from east to west. So whereas you don't necessarily see a ton of encroachment here in this analysis over the last 30 years here in Montana, we do have a strong signal that this is happening in Montana and it's starting to accelerate. So we've actually broken out here these different ecoregions across the West showing tree cover and rangelands. So the tree cover is on the y-axis, the year is on the x-axis. And what you see is that depending on where you are, the trends are a little bit different. We're seeing a lot of tree cover lost on the West Coast in California because they've been dealing with a 30-year drought. But what I want to draw your attention to is our region, which is the West Central Semi-Arid Prairies. This is area C here. And what I want you to realize is that since around 2010, we've started to see an exponential growth in tree cover expansion across this area. So this is probably attributable to a couple of things. First, from an invasion biology perspective, we often see this kind of lag period or slow period of growth before we see an exponential increase in change or in growth of a population. And that's actually very similar to this trend that we're seeing here. So what we're worried is that we're starting to see this kind of exponential growth or exponential spread of tree cover across the northern Great Plains. We think also that this is partly driven by drought cycles. In the 2000s, particularly, I think in the mid 2000s, we had some pretty severe droughts. Certainly later in the 2000s, we had droughts in Western Montana that had huge impacts on some of our forest resources. But what we really saw in the 2010s was these punctuated periods of both drought and very wet periods. So it could be both a climate response over the last, let's say, decade, as we've seen kind of this increased amplification both of drought cycles and of wet cycles, but also we're kind of seeing the point where we're reaching this kind of exponential growth phase. And what that's telling us is that we really need to start working hard on this threat if we're going to be able to get ahead of it here in Montana and the northern Great Plains. So switching gears a little bit, for those of you who work with producers, communicating woody encroachment from a biodiversity perspective, I think works with a lot of our conservation-focused colleagues or conservation-focused partners in the ranching community, but it doesn't speak to everyone. So we do know that woody encroachment takes land out of agricultural production. So this is some work by Sam Fullendorf. We have herbaceous production percent on the y-axis and years after conifer invasion on the x-axis. And what this really shows is that, at the start of the invasion, you really don't see any real decline in herbaceous production. It really takes a number of years, let's say somewhere between probably 10 to 30 years, for that decline in production to show up. But when it does happen, what you'll see is that production falls off the table. And I'll talk a little bit more about that just here in a couple of slides, but this work from Sam Follendorf, this is from the Central Great Plains, really matches some of the modeling that we've been doing here in Montana in terms of how herbaceous production changes in response to tree cover. So we've been working hard to understand where tree encroachment is resulting in losses of rangeland productivity. Across the West, we're estimating that these losses are roughly around 5 to 6% of total rangeland production. Again, a lot of this losses is focused in the Southern Great Plains, so Texas and Oklahoma, but we're starting to see this signal pick up in Montana. Across the West, these economic losses have totaled about $5 billion over the past 30 years, or $30 million annually. So what we've done, and I want to share a quick application here. And so the link to this will be included in the slides later, but we have developed a website that allows people to go in and look at both state and county level summaries of lost production. So this is a site at the workinglandsforwildlife.org site. Again, we'll share this link here a little bit later on. But what you can see is that you have the ability to zoom in to a state or to a county. And this information provided gives you information on changes in production, both at annual scales and cumulative scales. And so just as an example, so in Montana, in 2019, we lost around 300,000 tons of production. That's roughly around 500,000 round bales or food for 63,000 cows. That totals around about $7.7 million in revenue that's been lost to small producers. So if you're working with producers and want to be able to talk about the potential losses in revenue, this could be a source for you to look on. We can go into look at particular locations. So here we're looking at Powell County, Montana. In 2019, they were losing about 4.35% of their production, a total of 7,300 tons. So again, this is a great source of information if you're interested in being able to communicate this loss of production to producers. The Working Lands team has also put together this glossy handout. Again, you'll be able to click on this link once you have access to the slides to download it. But again, a good communication tool if you're working with landowners and want to communicate this threat as a way to help motivate them to deal with woody encroachment on their lands. Okay, so I finished our kind of broad overview of what's going on, both kind of from a global scale all the way down to looking at Western North America. So right now I'm going to now zoom in to what we've been working on over the last couple of years in collaboration with Montana NRCS. So we've had a CCG project that we started, I think, in about September of 2020 to look at mapping historical conifer expansion across the state. And so we have a manuscript in preparation. We'll have some resources available. This is a map of where we're seeing tree cover expansion and loss across the state. So areas in green are showing areas of tree cover expansion. Areas in purple here represent tree cover loss. So most of the losses here are attributable to large wildfires. This analysis covers a period from roughly the mid-20th century to 2019. Our base layer that we're using, our baseline data we're using is this Montana historical imagery product that we developed in the first part of this CCG for about the first year. If you're not familiar, we took historical aerial imagery from the 1940s, 1950s, in a few cases the 1960s, stitched them together from across the state and developed an application that allows you to view this historical imagery on top of kind of standard Google map imagery. So again, there is an application that you can go to view this imagery if you haven't seen it. There's also tiles available to download from our server here at the University of Montana. We've been working with Kevin Loberg at NRCS here in Montana in collaboration with the Montana State Library to get this data into a streaming service so that those of you who want to use it in your own GIS and don't want to go through the cumbersome steps of downloading data will be able to just stream those layers from the state library in the same way you're probably streaming the 2019 or 2021 NAEP imagery. So I think Kevin informed me that they're still working on that. Probably in the next few months or maybe by the summer, that data should be available for streaming. In the meantime, if you're comfortable, you can actually download individual tiles, but they're quite large. So to summarize 2 years of really hard work in a half of a slide, our conceptual workflow is actually fairly simple. We took the historical imagery and as well as modern imagery and developed algorithms that could identify tree cover. Or we could identify actual tree features or identify pixels with trees. We then transformed that into a tree cover layer. And then we did some simple math to understand, okay, where is tree cover increasing and where is tree cover decreasing? So we have this information now in an online web application, which I'll show you here shortly. You'll be able to download this data from the U of M servers. If for those of you working in GIS, if you want to have immediate access, and then some of this data is also going to be available from the NRCS portal immediately, and then more data from the state library through time. And so before I actually show you the application, I want to give you the big picture. Based on our analysis, we're seeing woodland expansion in roughly around 7.4 million acres of rangelands across Montana. That's roughly around 15% of all rangelands in the state. We did catalog some loss as well on the order of around just shy of 1 million acres. But what we're really seeing is this proliferation of tree cover across the state. In these open woodland areas, we're seeing the closing of woodlands as they densify. In areas, a great example would be the Missouri River breaks. We're seeing these woodlands that existed down low near the river. We're seeing expansion of those trees up out of these coulees, up on top of into some of these high quality shrublands and grasslands that exist above the Missouri River. And then in the western part of the state, we're really seeing the descent of trees out of these primary forests into our intermountain grasslands. We're seeing the infilling of mountain meadows, which are important habitat, winter habitat for wildlife. So this expansion is occurring across the state. And I'm going to be blunt with you folks, is that we probably don't have the ability to stop this. Instead, what we're going to have to do is we're going to have to focus on these places that are of high quality that we want to protect into the future. And so the folks at NRCS, with your colleagues in the BLM, Forest Service, and at the state, you guys are really going to be selecting these areas that we're going to be able to preserve into the future, because it's unlikely that we're going to be able to deal with woodland expansion everywhere, particularly if we're not able to put fire back onto the landscape at large scales. So to support this work, the Working Lands for Wildlife team has developed this Defend the Core, Grow the Core perspective, I guess framework, I should say, where we're trying to identify these intact core areas, in this case, core grasslands, core shrublands that have not been invaded and are currently high quality. Focus our restoration efforts on maintaining those intact core areas and then pushing out from those intact core areas into these transition zones to try to regain habitat where we can. And so kind of flipping on its head this kind of traditional response where we've basically been ambulance chasers going to these highly degraded sites, putting a lot of good work on the ground over a fairly small area, which may be highly degraded, but then having no real connectivity to the larger landscape. And so we're asking folks to think hard about this. Again, this is kind of central in the frameworks that we've talked about at the Working Land site. And I'd ask you to reach out to us at the University of Montana. Certainly, Jeremy Maestas within the NRCS Working Lands for Wildlife team is a great resource in how to kind of understand and implement this defend the core, grow the core strategy. So just as a general example, so this is coming from the Great Plains. We have an area of invaded grasslands here on the left. We have an area of an intact core area here on the right, and then there's a seed contaminated area that's kind of in between these two. And so when we're thinking about managing for a defend the core or using a defend the core strategy, really we need to be able to first delineate these areas on the landscape, focus our attention on these seed contaminated acres where we're seeing these are the phase 1 sites where we're seeing just a few trees kind of come in, get those areas under control before we try to push out and do the work in these areas that have already expanded. This is the way that we're going to be able to get to scale and addressing woody encroachment, is to make sure that we're addressing these phase 1 or these seed contaminated areas first, that allow us to work at large acreages for relatively little amounts of money, and put a lot of acres on the books to protect these intact core areas. Okay, so I'm going to try to do here a demonstration of the new application. And so if those of you who have worked with the historical imagery application before, so that was available through rangelands.app, you're going to see a lot of similarities here. So what I'm going to do is I'm going to talk about the functionality first in this web application, and then I'm going to kind of try to walk through a quick example of how you might use this. And so what you're going to see first is that there is a central slider bar that allows you to move, allows you to swipe that historical imagery back and forth across your screen. So you can compare that historical imagery to the modern imagery. This provides a great check on how well we're doing in terms of modeling conifer expansion, and is also a great way to kind of story tell how conifer expansion is occurring in the landscapes that you're working on. What you're going to see on the right panel is a woodland expansion is shown in these colors that are roughly kind of tan to dark red. Areas in black represent tree cover loss. So these are areas that have had large fires typically. You also have the ability to turn on these sagebrush core habitat layers that we talked about earlier. And so it's important to recognize here, I think maybe some of you are very familiar with the sage grouse core maps or the PAC data that has driven a lot of conservation work before. I want to say that there is a distinction here, and because this product is different in that it's not focused just on sage grouse, but is focused on sagebrush habitats across the West. Okay, so you have the ability to turn that layer on and off. And then there's also, you can control the opacity of these layers as you're looking at the data. There's also some featured locations, and I'm not going to go in that today, but you can open that up. And that allows you to look at particular locations where we've seen some substantial tree cover expansion. So I'm going to zoom in here to this area right around Ringling, Montana. So this is on Highway 89 south of White Sulphur Springs, on the way to Livingston in the south. So kind of just northwest of the Crazies. And so we're seeing here, again, a lot of conifer expansion, both from these woodland patches in the uplands that are expanding down into sagebrush country, and then also expansion coming up out of the coulees. And so one of the ways that you can use these data, particularly in a defend the core type approach, is that you can understand where these core areas are located for sagebrush on the landscape. And so here, green represents these core sagebrush areas. These are the high quality sagebrush grasslands or shrublands that we've been mapped, and then the purple represents the areas that are growth opportunity areas. So still quite good habitat, but are under some threat due to some kind of ecosystem or land use change nearby. And so what I want to talk about just briefly is that when you're thinking about perhaps developing tips or developing strategies to deal with woodland encroachment in these systems, I think most of us want to look at these areas that have had the highest amount of change. And I think I'm going to zoom in here on this coulee right here and say that we need to enact our conservation actions or our tree removal in these areas that are already been seeing the highest amounts of tree cover expansion. But in fact, the better strategy is to look at these areas of expansion relative to these larger core areas and say, okay, how do we ensure that these areas of conifer expansion that we're seeing coming out of these coulees or down out of the upland woodlands, how do we develop a strategy to work along these edges to ensure that they don't have further migration into these core areas? So if you can develop then a strategy that allows you to understand where the tree encroachment is happening and draw some of these lines so that you can understand these dispersal areas and where you need to stop woodland encroachment from expanding into, you're going to be able to cover a lot more ground. And you're going to have a larger impact on some of these key ecosystem features that we're key ecosystem components that we're so concerned about preserving. So, we're looking here at a core sagebrush area of roughly around, I think well, I'll wait for it to come back up here. So this green core blob of core sagebrush habitat, I think is roughly around 50,000 acres. But here, what we can do is we can work on developing a strategy where you're maybe implementing work on, phase one, maybe a couple of thousand of acres that allows us to stop the encroachment at these edges. So stop the encroachment out of these coulees. I think this is 16 Mile Creek here, and protect this core into the future. And so when we put maybe 2,000 acres of phase one conifer removal on the ground in a location like this, what you're really seeing is a multiplicative effect. You're not just, impacting 2,000 acres of shrubland. What you're doing is that you're protecting 50,000 acres of core habitat. The mapping tool also then provides a better spatial context for how some of these core habitats are connected. And so very interestingly, if we zoom way out and look at this core habitat model, this area between kind of mid-canyon, so southern Cascade County, down through Marr County, Ringland area towards Livingston, this is a really important connectivity pathway, both for some of these rangelands along the Rocky Mountain front, connections to southwest Montana, and then connecting into the greater sagebrush habitats that we see in eastern Montana includes these large core areas up north of the Missouri River in Phillips County. So the map not only shows you where conifer expansion is happening, it allows you to provide the spatial context you need to understand where to put work on the ground. So I just want to conclude this phase with saying that I selected this location in Ringling having very little awareness of other issues that might affect adoption of work in these areas. Certainly, I'm not suggesting that this is the best place to put work on the ground. A lot of the work that you guys are doing, being that it's with landowners, is about cultural will. And so in some cases, it very well may be worth putting work on the ground, even if you're outside of a sagebrush core area. There's other, threats that we're dealing with in terms of habitat loss, maybe in terms of protecting property from the threat of wildfire. This is just one example of how you can use these data in a spatial way to give you the context that you need to put your work on the ground. These are some backup slides in case the web app didn't work. Okay, so you're also, we're kind of finishing up here, but you're also going to have the ability to use this data in GIS. So for those of you who are more comfortable working on this with this information in ARC, so you can measure things, so you can make high quality maps for some of your proposals or work plans, this data is going to be available to you. So Kevin Loberg was helped us in getting a vector data set for the tree cover expansion available through the NRCS portal. And so you'll be hearing about that shortly from some of the NRCS staff. We have both the rasters and the vector data also downloadable from the University of Montana servers. So if you're more of a savvy GIS person, you'll have the ability to go and download that data directly from us. The historical imagery is also available. I'm just going to warn folks is that the imagery itself, if you're downloading it directly from us, those files are quite large. And so depending on where you're at, I'd probably suggest if you're going to try to download tiles, download them from your central office rather than from a remote work locations. And then finally, the sagebrush core areas are available from the USGS Sciencebase website. And so just briefly, I want to go over using this data in a GIS. So I have Arc Pro open here. And effectively, you're going to be able to download these same set of layers and visualize them in the same way that we have in the online application. So again, here we have the historical aerial imagery that you can bring in and out. We've provided the sagebrush core areas as well. I do just want to talk, though, really briefly about this vector data, because there is actually one additional, I think, useful tool here. So I'm going to zoom in to one of these sites. And so with the tree cover expansion layer that we're providing, we're showing the areas that the model is finding tree cover expansion, but then we're classifying these pixels as either grasslands, shrublands, or woodlands based upon their historical vegetation class. And so we're using the biophysical systems layer from the, biophysical systems layer from the land fire system to determine whether or not the pixels in which we're seeing tree cover expansion were grasslands, shrublands, or woodlands. So for some of your work, you may want to actually turn off some of the expansion that we're seeing in areas that were classified as woodlands. Or maybe you want to focus on areas of woodlands if you're interested in trying to understand where tree densification is for fuel removal projects. But that gives you an additional layer there to work with. Also, then it makes it much easier to use some of the standard GIS tools. If you want to do some area calculations, you can clip these data, you can filter them, et cetera. So all of these data are going to be available to you either directly from the NRCS portal or downloading from the University of Montana servers. Okay, so that kind of concludes my talk for the day. I just want to leave you with a few kind of take-home messages. If folks have not been exposed to this defend the core, grow the core strategy, I really ask that you take some time, go to the Working Lands for Wildlife website, take a look at the frameworks there, some of the additional resources that we have, and begin to understand it. I've presented you a case looking at sagebrush cores, but that's certainly not the only way to use this defend the core strategy, right? When talking about woodland expansion, there's all these issues that are related to habitat, fuels reduction, community safety that can be applied. So I don't want to suggest that we should only be removing trees in these core sagebrush habitats. But this general strategy of understanding where on the landscape can we protect kind of these high quality characteristics, where we can put a lot of work on the ground for relatively little amounts of money. So this is working in like phase 1 encroachment rather than working in phase 2 and phase 3. These are really important components if we're going to be able to get to the scale that we need to save some of our landscapes. Second, if you are working in sagebrush country, please take a look at that new report from the USGS and Fish and Wildlife Service on the strategies that we're starting to try to implement to preserve and save these ecosystems across the West. Again, we're losing about 1.2 million acres of sagebrush per year, and we're starting to try to ramp up strategies to address this. Three, use our expansion app to investigate where tree cover is expanding. So I'll be providing the link in the chat here. I encourage folks to go take a look at stuff. And finally, talk to us or reach out to us with your questions. We're here to help. We want to know how you're using these data. We want to know what the challenges you have to actually taking the data that we're producing in our science shop and getting to solutions on the ground. I know that I think either Katie or Kyle will be talking here kind of afterwards. They're going to be kind of acting as liaisons for us in this case, but we really want to help folks in using this data across your landscapes. So we're really excited to know how people might be using this data.